Yes, hi there. Welcome back. Here's an quite interesting production tutorial by custodian networks or data centers in UK, where they have shown how things are in fact done. And I've not seen this part in particular yet, but something else from them, which I can't exactly show you right now because uh, it's so lengthy. But if you can follow me for 10-15 minutes, then I'll try to see what they are doing. And I'm not prepared anything to say for you. So thanks for your patience. Let's roll it.
So we connected to the switch via a serial connection. I've got it plugged in here, and we're actually going to run some commands on the switch to do some basic diagnostics. The first thing I'm going to show you is checking the status of the switchboard, and then we're going to move on to looking at cable diagnostics and spanning tree. So at some point, this screen will pop up in full screen so you can actually see what I'm doing. Okay, so the first thing we will need to do is if you want to view the status of an interface, you're going to go on port 44 here. This is a switch I'm connected to. So you've got two types of show for the interfaces. You've got a show run, like this, not like that, like this, which will show the running config, but we don't want that. We just want to show the GI044. So what this will do is it's showing me the status of this interface. So on here, I can see here that we've got full DFX support and it's up at 1 gig here, and it also tells me it's a copper connection. We've also got that it's up and connected. If I disconnect it and then run the same command, it will say the line protocol is down, not connected. So the port is down, but still enabled. So this is very good for diagnostics in the way that we sometimes have customers report issues. And when it's like this, we can see that the port is up on our side. The actual port itself is down, and it's not connected. So if I reconnect this real quick, you'll see a few errors come up because we've got it plugged into another bit of kit. Just for demo purposes. Okay. So go back to the original show link. So now the protocol is up and it's connected. It tells us it's gigabit Ethernet. This is press that port. Gives us the port description, which James said in the last video. Keep alive, whether it's full duplex, half duplex, and what speed. So sometimes if you've got a cable that's miswired, this will actually show 100 meg, half duplex, whatever it might be. So that's a very basic level. This bit here also gives you various information. So you've got input errors and CLCs,
Starting up switches, etc. I'm not. Um, yeah, I've not exactly been into this for, let's say, I think it's 10, 13 years ago. But I'm just trying to understand that the operating system, etc., is starting up the servers or actually switches, and let's see what happens next.
So, looking at that, it's a very basic level of understanding. What I'll show you now is the cable diagnostics. Now, James beside me has a pair of scissors, and what we're actually going to do is we're going to cut one of the cables, and then we're going to rerun the test so you can get an idea of what's actually happening. So if I run the cable diagnostics before, it'll do a TDR. which will basically tell us the length and how it's wired, whether it's wired correctly, whether there's any short circuits, or whether there's wires or cords missing. So, the test, cable diagnostics, and we want a TDR on this one. So we'll test cable diagnostics TDR, and then we need port. So we'll need 44. That is a plain ball. Okay, so now it's literally telling you what it's going to do. Take a few seconds, and then you can use the show cable DVR. See the results. So if you show cable diagnostics DVR, okay, so you can see here everything on the board is normal. So
Starting up virtual local area networks
green cable here,
with Giga Ethernet. It's typically switches, routers,
it gives you
which they have started up.
give or take meters, and the status from that pair. And my legs are going sat down here. So it gives you the status of that particular cable. So this cable is perfectly fine, but we can make it not fine, can't we? We are. So this is yes.
If I cut this cable, why do you cut it a little bit?
It only needs to be cut enough just to get a core that's broken, and then the TDR will show it. This cable here.
Okay.
One core broken, one actually split. We just have a little manipulation of the cable guy and cut some of the cores together again. Might do something, apparently not. But we can now run the TDR again. So if we rerun this TDR, G044,
That is not only troubleshooting, but practical or physical troubleshooting.
So it's not yet updated, so it's probably still running its test. So just to rerun the test because it apparently didn't run, I think
Yeah, by doing this, they can test whether cables are working correctly, whether switches, servers, etc. is working, or the operating system or software is working or not. There are many things you can find out by troubleshooting physically. I've not done this for I think 12 plus years now, but it was a heck of an important job. So roll on.
the results too quick on that one. So give it a little second more this time. So it took a little while to get there, but now we can actually see that at roughly pair D, roughly 1 meter. So this is a D cable. That's white orange, green, white blue, white blue, green. You see the brown, white, brown, pair D. And that is exactly what James has cut. So it's saying at roughly 1 meter, there's an open pair, which, yes, it's not exactly 1 meter, it's probably half a meter, but it's guesstimated. It's just a TDR function on a switch. If you use an actual TDR tool, you probably get a more precise reading. But this shows you that here there is a particular problem with that pair. We could use this to diagnose that it's either a bad crib, someone's cut the cable maliciously, or that there's just a general fault with the port. The port itself could have a fault with the pins. So this aids in that diagnosis. So the last one we're actually going to look at, which I can do, we're going to do 441, but...
And I just came to remember that you'll see that some of the UTP cables, network cables, etc., they are quite short, while others are very, very long. And that is, they keep some of them short so that for the first part, you don't confuse what is going from where to there. And the other thing was, I think, that you're just it's much so-called connect and test. He's using a um, notepad there, but in some environments you have terminals, etc., where you log on. But this is about troubleshooting, so I believe that this is more convenient and accurate way of doing things professionally, where you can just take your PC from the office and go and smack and fix up things.
Those are part of the port channel. So what we need to do is we can do show spanning tree, and let's go VLAN 1. Okay, and I'll also do VLAN 2,
Mm.
so we've got more on the screen. So what we've actually got here is the VLAN spanning tree information. So here, you can see, so VLAN 1 spanning tree is enabled. It tells you the warranty, and here we've actually got information on where that VLAN is sitting. So if we were to do a show on interface port channel 2, you would see that interface is happening to VLAN. So it's currently in full state. It's got a cost, it's got a priority, and it's time. That is the relevant time at the moment it works. Obviously, if there was a fault with it, then it would show us here, giving information, but I don't really want to start with that. So again, you've got the VLAN 2. It's also encoding these two ports. Now, you might think, how come keep port 4 still encoding and saying, yeah, cables are cut? Because the port's still up, but it's only up at 100 meg, because James cut ground twice. So if I actually do that showing just on that interface, you'll see that.
And usually, if you're starting up switches and routers or whatever that is, equipment, devices, and so on, then you normally have to just run through all procedures here in the console and then check what is not working and so on. Because right now it was a delay on 15 seconds, which could mean that things are not working. But when it comes to network connectivity with multiple devices, then you can also cross check like this.
First glance, keep port 4 is up, one controls up. Perfect, everything comes glory. If we come down to here, it's only up at 100 meg. So what this is telling us is spanning tree is working fine, the port's up, and you're only going to get 100 meg on that port. So if that, do you want to cut that cable completely? Let's cut the cable completely, because I want to just see what the spanning tree does. So now that interface is actually completely dropped off of VLAN 2 because it's cut. So there you go. If there was a loop, it would show different information. We're not going to simulate a loop. That's not what this video is about. But what we've talked about is the show interface to actually tell us the states of the interface, whether there's port errors, speed, etc. All the stuff that we need for a basic level of diagnosis. We've also covered checking the spanning tree is actually a full state, it's not going to be in a rotten state or something.
Not very easy to hear.
And we've also covered doing
Much noise.
diagnosis of the cable, give us a fault, what distance, what pair it's on. Obviously, you get different metrics if you fiber because you don't have cores, and you probably use an actual OTDR test to like graph use it. Now I'm waiting for this native VLAN mismatch to come up again, just so it's kind of not filling up the screen. But I'll quickly talk through what it's doing before it comes back up again. I think it's coming up every couple of minutes. Effectively, what it's doing is it literally goes into the problem. So a bonus error we've got here, guys, is we've actually, because we cut the green cable, we've had to swap over the cables on this switch, and it's actually reproduced the error that I want to talk about. So looking at this error, you've actually got quite a lot of information. So it's giving you an error message, which you can use to look up in Cisco documentation. So you've got CDP, native VLAN mismatch. CDP is Cisco Discovery Protocol, and it's telling you that there's a VLAN mismatch between the port on this switch and the port on the other switch. I don't know what I'm pointing at. So this will say that the VLAN mismatch is going to be Ethernet 044 and it's 2. Now I know that this switch only has like a single set of what ports, a single slot switch, so it's 044. So if we were to log on to this router, so the one that the other end takes to E435, this and this will be back to front. But for this one, we've got VLAN mismatch. It's got an E044, it's currently VLAN 2. And it's telling us that the other end, which is plugged in at E435, currently on VLAN 20, so it's good to have a fuss about that, because Spanish tree kind of works when both ends are on the same VLAN. So, yeah, with this, again, it could be, for this particular video, it's because that port is 420, it's not configured to do anything special. So we can
Yes, okay. I thought they were going to show some tricks and tips, but they just did not go any further there on doing anything else. So yeah, I think it was not very interesting exactly, but let's just hope that the other videos are a bit better. So you can share your opinion with me.
No, and I don't really have a plan for the next video, so if anyone wants to do something very specific, feel free to mention that.
Same there.
See you next time. Happy
Bye now.